In this video, we're going to do the problem, a gas is in a container of fixed volume. The pressure of the gas is 200,000 pascals. Some of the gas is let out of the container so that 2/3 of the original amount is left. At the same time, the temperature of the gas is doubled. What is the new pressure of the gas? This means that we're going to look at the relationship P2V2 over P1V1 equals N2RT2 over N1RT1. So first I need to write down how the gas is changing. So what is state 2 compared to state 1? The first thing we're told is that the container has a fixed volume. That means that V1 equals V2. And we know that the initial pressure is 2,000 pascals. Some of the gas is then let out so that 2/3 of the original amount is left. The amount of the gas is represented by the number of moles. So N2 is going to equal 2/3 of N1. And then the temperature of the gas is doubled. So T2 equals 2 times T1. And our goal here is to find P2. All right, so if I go back up here, I can cancel out V2 and V1 since they equal each other. And we can always cancel out the ideal gas constant since it is a constant. That leaves me with P2 over P1 equals N2T2 over N1T1. So P2 is my unknown. P1 is 200,000 pascals. N2 is 2/3 of N1. And T2 is 2 times T1. And then we leave the N1 and the T1 on the bottom. I then can cancel out the N1s and the T1s. So it's going to leave me with P2 over 200,000 pascals, 2/3 times 2. That means I'm going to take P2 is equal to 4/3 times 200,000 pascals. All right, so I'm going to get my calculator out to do this one. That means that P2 is going to equal 266,667 pascals.